Hello? Hello?
Yes, sir. Yeah.
Oh, okay.
Okay.
Just I will start. I'm talking about
Okay.
this. Just I will review. We're talking about the learning rules. In the learning rules, we're having supervised learning, unsupervised learning. In the supervised learning, I'm talking about perceptron learning, withdraw of delta rule. In the delta rule, what we are seeing delta rule or delta learning, that is every rule we should compute change the weight expression. Delta Wji is proportional to the minus gradient of the error. Therefore, to remove this proportionality constant, I'm using eta minus eta gradient of the error. There I stopped. Therefore, in this one, first of all, I want to talk about this error. What is the error? Suppose if you take, as we have seen, when we are having this neural network, okay, and we're having some 10 patterns are there, for example, we should give more number of patterns to train the network. Okay, I will give first input. I will get this is your okay, this is your corresponding decay, corresponding this input. Okay, this is the output. I will get error E1. I will not modify the weights. I will give second input X2 somewhere other. Corresponding this X2, another desired output will be there. That is, assume it is efficiency inputs of the transformer, the output of the transformer, that is efficiency of the transformer. Let us say it is the inputs. Input is nothing but output of the transformer, iron losses, copper losses, etc. Inputs corresponding to efficiency. I'm calling it the desired output. If this input is changed, this output is also will change. Therefore, once again, I'm repeating. This is your structure, topology of the network. Weights are initialized. I given some input. I will get the output OK. Dk minus OK is the error even. I will keep as it is. I will give second input. Then once again, I will get OK. I will get the desired output. E2 I will get. Like that, 10 patterns are there. Then I will get E1, E2 dot E10. I will get 10 patterns. Therefore, suppose if you add all these patterns, then what happens? Some errors may be positive, some errors may be negative. Therefore, assuming error positive and negative both are equal, this error becomes zero. If error is zero, I cannot update my weights. I cannot calculate my change in the weight expression. Then what people will do is that they will take square of the errors, sum of the square of the errors. Suppose if you make it square, definitely your error will exist. Therefore, this error I can write total error. It is nothing but your dk minus ok whole square and summation. Then what is this dk desired output? What is the OK? OK is nothing but function of the net. What is the net? W transpose of x whole square. And one more thing, what people will do is that I want gradient of the error means I want to take the differentiation dou e by dou w. Dou e by dou w we are calling as the gradient of the error. Therefore, if this is the error, if take the derivative dou e by dou w, then 2 will come into picture, 2 into so and so. The 2 is constant. Then what people will do is that they will multiply with 1 by 2. Therefore, why 1 by 2? If a 2 will come, 2 will get cancelled, the constants. Okay. Therefore, error is nothing but once again I'm repeating. We are using sum of the square of the errors. Instead of I will present pattern 1, I will get error E1. Pattern 2 input, pattern input 2, I will get error E2 like that. After just if I add algebraic sum, if you do, then there is a possibility is that error may become 0. Therefore, I'm making square of the errors, E1 square plus E2 square plus E3 square dot E10 square. Then it is if error is nothing but dk minus ok summation dk ok output of the ok whole square. Therefore, what is the ok is nothing but function of W transpose of x. It is net. Okay, this net what we get. What is the function? Suppose we are using a sigmoidal activation function, your output is 1 by 1 plus e to the power of minus net, like that. Therefore, suppose if you take this is my error, I want gradient of the error. Then what is the gradient of the error? If it is the derivative, gradient of the error is nothing but your dou E by dou W. Then what you will get? Here you will get 2, 1 by 2 is there, 1 by 2 into 2, your dk minus this as it is I will get, that is your f W transpose of x into we are taking derivative with respect to this weight dou E by dou W. I will get f dash of net. Net is W transpose of x into x. I will get. Therefore, in this one, the gradient of this change in the weight expression equal to minus eta. Okay. What is the gradient of the error? You are having taking the derivative with respect to this one w. W is having some minus sign. Then here also I will get a minus sign will be there. And this 2 will get cancelled. Therefore, what I will get here is that this substitute the value minus dk minus ok. Okay, this f dash W transpose of x is nothing but ok into what you will get f dash derivative of your net k into whole your x input, this x. Therefore, here what is happening is that minus become plus. Therefore, you are changing the weight expression, which is equal to eta into this x. This is your dk minus ok into f dash of net k. This is the expression. This is we are using delta rule. Delta rule, what is the requirement? The requirement is that you require continuous activation function. You require continuous activation function. Okay, whether it is sigmoidal activation function or we can have the a tan hyperbolic activation function, you can consider. Okay. Now in this one, okay, in this one, what we have seen, the first one is that perceptron learning. The requirement is that it requires linear activation function. Therefore, the change in the weight expression, what you have seen, it is nothing but eta into your dk minus ok into input. That is what we are calling some x. Whereas in case of the delta rule or delta learning rule, it requires a continuous activation function. Therefore, the change in the weight expression, what you have seen is nothing but your eta into your dk minus ok, the derivative f dash of net k into input, that is x. Now, last one, which is what we are talking is that this is the last one, withdraw of learning rule. In this one, there is no activation function at all. There is no activation function. In the first one, what is in perceptron, linear thing. Delta rule, we have considered continuous activation function. In the withdraw, there is no activation function. Then when there is no activation function, what you will get? Then if you see, as you have seen, change the weight expression, delta WGI, which is equal to eta into dk minus ok, this whole into input x. Therefore, what is the OK here? This OK is nothing but eta into dk is the desired value. Output is, you have seen, function of net into x. What is this function? there is no function existing here. There is no activation function. Then what happens here? Your eta into dk minus net. What is the net? Net is nothing but your W transpose of X into X. Therefore, in this one, the supervised learning three types. In the once again, in the perceptron learning, changing the weight expression is that eta into di minus oi xi, but the we are using activation function is the linear. Delta rule, we require a continuous activation function like sigma del activation function, etc. There is change in the weight expression is the eta into di minus oi into f dash of net, okay, into total into xj. Withdraw off, there is no activation function at all. There will change the weight is that eta into di same di minus oi into x. What the o is nothing but function of net. The function is not there. Therefore, my output is w transpose of x. Therefore, like this, we will use the based upon the what type of activation function you are using. We will use what type of learning based upon the paradigm. Now, next one, what we are having unsupervised learning. In the unsupervised learning, we have seen two types. One is the heavier learning, another one is the competitive learning. In this competitive learning, also known as winner take all learning. Winner take all learning means the word which has come from the game. Suppose if you take a cricket, if you play a cricket, what happens? There is a winner will be there, a runner will be there. Therefore, what winner, whatever you will get prize money or etc., you will get large amount you will get. That is why winner take all learn. With the loser or runner, you will get some money, but very small. That is why it is a competitive learning, okay, or we will call winner take all learning. Once again, the word which has come winner take all is that from the game, from the sports, okay, who will win, he will take majority, okay, he will take everything, okay. In this one, unsupervised learning, suppose if you take a single layer network, these my inputs are xi, xj, xn, okay, my outputs are oi, oj, on. Then what here there is no, we should not use any activation function here. Okay, I will explain. Okay, now I'm talking. Winner takes all. Okay. It is unsupervised learning. Suppose we are having, these are my inputs. And these are my outputs. Inputs, these are my outputs. And all are interconnected. And there is no activation function in this one. Then who is the winner from the base of my outputs? Let us say some x1 and x2. I will use x1 equal to 1, x2 equal to, I supply some values. These are the weights, initial weights, the ith layer and jth layer. This is your wji. W11, W12, W13. Okay, what is the output here? This is the x1, this is the x2. Therefore, here what we will do is that to determine the winner, I will calculate the net. This is the net 1. Okay, this is node 1. This is a node 2. I will call this is your net 2. This is a node 3. I will call this a net 3. If you see in this one, what is the net 1? Net 1 is nothing but x1 w11, x1 w11 plus x2 x2 w21. I supply the values x1 and x2 values and w1 w2 initial bits you supply. I calculate some net 1. substitute and calculate net 1. Let's say net 1 is some 5. Okay. I'll calculate net 2. What is the net 2? X1 W 1 2 plus X2 W 2 2. Then what I will, if you calculate, I will get, let us say it may be some 8. Net 3, I will calculate. What is the net 3? X1 W1 3 plus X2 W 2 3. Therefore, let's say I will got 15, some value. Out of this 3, which is the highest? This 15 is the highest. Therefore, what I will do is that I will make this node 3 as the winner. Node 3 as the winner. These are the losers. If this is the winner, what I should do? I should update weights only. These weights only I should update. The weights which are going to the node 3, those weights only I should update. Then in the unsupervised learning, what we are doing is that how to compute this change in the weight expression. That is delta W expression. Suppose this is the ith layer, ith node, this is jth node, this is mth node, for example. M is the winner. Then what we will do is that delta Wm, how many weights are there? Only 2. W, M1, W, M2, we will update. We will not update. How many weights are total? 3 into 2, 6 weights are there. But I will update only winner weights, only 2 are there. These 2 will update. Sorry, this is winner, Wm. Okay, sorry, not delta, Wm. Then how to calculate change in the weight expression? The change in the weight expression, in case of unsupervised learning or delta rule, delta Wm, which is proportional to the x minus Wm. Your x is the input and Wm is the winner weights. Therefore, what we want to do is that the input should match. If this is the input x, graphically, if you want to show, if this is the x, but W1 should also be in phase approximately. Then it will classification become easy. Therefore, the expression we are using, change in the weight for the unsupervised learning, that is winner takes all or competitive learning, is proportional to x minus W1. What is the x? X is the input, Wm is the winner weights. Therefore, your change in the weight is equal to eta x minus Wm. Simple. Therefore, eta is the proportional constant. Already we have discussed eta should be small. Okay, here also same thing is valid. Some eta will take some 0.1 or 0.2, something like that. You will proceed. Therefore, the most important thing is that here, just if I review, we have what I discussed so far is that the first one is that I discussed modeling of the neuron. After modeling of the neuron, next topology, connectivity. That is, in the connectivity, what we have seen, there is a feed forward neural network and feedback or recurrent neural networks. And one more thing, what you have seen, single layer network. What is the limitation of the single layer neural network? The single layer means some input layer and output layer will be required. Because input layer is not processing, only one output layer is there, we'll call single layer network. In the single layer network, what we have seen, it is cannot do at the time in 1940 and others, when scientists are working, they know only single layer network. Single layer network cannot solve even a simple classification problem like exclusive OR problem. Therefore, then what we have to do? Then we converted single layer network into multi-layer network. Have you discussed how you have considered multi-layer network? The multi-layer network we have considered by adding some hidden layer nodes. Then how to select hidden layer nodes? Hidden layer nodes should be more than the input layer. How much more? How much more means approximately 1.5 times the input layer nodes. Then what we have done is that we are discussing learning loss. What is the need for the learning loss? The need for the learning law is that we have to update the weights. From the learning law, how to update the weights? The expression we have seen, W new equal to W old plus change in the weight. Any learning law, it may be supervised learning or unsupervised learning, you will calculate change in the weight. Delta W expression, you will calculate. Therefore, in the supervised learning, we have seen 3 types. One is the withdrawal of learning, another one is the perceptron learning, another delta rule. For all the 3 different, we are using In case of supervised learning, in case of delta rule, we required continuous activation function is required. In case of withdraw off, there is no activation function at all. In case of perceptron learning, we require linear activation function. Whereas in case of unsupervised learning, unsupervised learning, we're having Hebbian learning and competitive learning. The competitive learning is very powerful. People will use very frequently. Therefore, in the competitive learning, to compute the change in the weight expression, delta W equal to eta into x minus Wm. What is the Wm? Winner weights. We will update the weights only winner. Loser weights, we will not update. That's why we are calling winner takes all. Therefore, in this one, that is inputs are xi, xj, xn, outputs are oi, oj, on. Therefore, we will calculate the net of node I, node j, node n. Whichever is the highest value, you will take. Now, if you take, there is one issue is there. Suppose two nodes, two nets are same. Then how you will take? Both are 15, 15. Then your choice. You can take either second one or first one of 15. Your choice. Because if you take, for example, any game, group A, group B, they made same score. Then what people will do? Several ways. One is a toss. Therefore, head and tail. Therefore, based on that one, they will decide the winner. Similarly, here we will take when both are same values are coming into picture, we can take anyone as the winner. Therefore, this change in the weight expression for the competitive learning or unsupervised learning, eta into x minus W, where eta is the learning rate and x is the input, Wm is the winning neuron weights. Okay. This is a Hebbian learning, but Hebbian learning people will not use. But anyhow, I will talk about. Suppose two neurons are there, neuron I, neuron J. And the neurons which are connecting the ith layer and jth layer, I'm calling this a Wij. Output of the node I, I'm calling is the out I. Output of the jth node, I'm calling as the out J. Therefore, what this Hebbian learning says, by change in weight expression, the change in weight expression is given by, is proportional to, it is a product, sorry, it is minus is there, it is not minus, product of out I minus out J. Therefore, eta is the proportionality constant, where Wij is the change in specific weight connecting neuron I and neuron J. Out I is the output of neuron I, out J is the output of neuron J. Okay, then once again I'm repeating, in the Hebbian learning, change the weight expression is the eta into Wi, it is into Wi into W, out I into out J. Okay. Therefore, for this any learning law, either supervised learning, 3 types we have seen, unsupervised learning, 2 types. Our objective is that to compute change in the weight expression. After computing the change in the weight expression, we can update the weights, that is W nu equal W old plus change in the weight. The process continues. Suppose if you see, what are the requirements of the learning laws? Because these learning laws are the what I will say is that heart of the neural networks. Because without these learning laws, I cannot proceed to any paradigm. Because there's what are the paradigms? Back propagation algorithm, radial basis function neural network, functional link network, okay, self-organizing map. Several algorithms are there in the algorithms or paradigms are there for the neural network. To understand the algorithms, we should know learning laws. Then what is the requirement of the learning laws? Either it may be supervised or unsupervised. Learning corresponds to parameter changes. What parameter is changing here? Weight parameter is changing. We have to change because all learning laws, I'm computing change the weight expression. To update the weights, we require learning laws. Therefore, learning corresponds to parameter changes. Second point, the learning law should lead to convergence of weights. Then what happens here? Every time we are modifying the weights and once again we are giving the input, we are updating we are reducing the error. Therefore, the learning law, whatever the learning law we are using, it should lead to convergence of the weights. The weights should be stabilized at the end. After 1,000 iterations or 2,000 iterations, okay, my weight should be stabilized. Otherwise, there is no use of learning law. The learning or training time for capturing the pattern information from samples. Samples means input, patterns are inputs from samples should be as small as possible. One more thing I want to say at this juncture, before explaining this third point. Suppose daily I'm watching a TV serial. Daily at about 8:30, I'm watching a TV serial. Then what happens here in the TV serial? In the TV serial, every 5 minutes serial is over, some advertisement. What is the advertisement? My Sony TV is the best, or LG washing machine is the best. Let us say I'm watching that serial since last 3 months or 4 months. In that process, what happens every day? What it says by Sony TV is the best, or please mute your mics, please. Hello? Hello? Please mute your mics. Hello? Okay. Daily when you're watching a TV, in between when advertisements are coming, since last 3 months or 4 months you're watching the TV, therefore suddenly your TV, some issues are there. It is not working well. Then what you want to do? You want to purchase a new TV. If you want to purchase new TV, which one you will purchase? Daily, which is a TV in the advertisement is coming? Sony TV is the best. I will go to a shop. In that shop, is having Panasonic is there, LG TV, several TVs are there, but there is no Sony TV. But your mind become biased. Which is the best TV? Is the shop owner says it works better than Sony TV and all that, but you're not happy because since last 3 to 4 months you're hearing Sony is the best, Sony is the best like that. Suppose if the TV is not available, Sony TV in the particular vendor shop, okay, you will go to the next shop. Suppose in the shop Sony TV is available, immediately will purchase. That is what happened. Your daily, when watching the TV, your mind become trained. Best TV is that, so Sony TV is the best. Daily we are saying Sony is the best, Sony is the best like that. Therefore, in the third point, if you observe, learning or training time for capturing the pattern information from samples should be as small as possible. Here, what is happening when we are showing every time, okay, some picture that is Sony TV, what happened? My brain has captured Sony TV is the only best. Therefore, if you show that there is some I want to train the network for a particular problem. What problem? To compute efficiency of transformer or load flow analysis, etc. Then what happens? Large data is required. You have to generate the data. Okay. How to generate? I will explain in the next class. Okay. Therefore, if you show the data every time, what happens is that the weights goes on modifying. Weights, it may take 100 iterations, 2000 iterations. For sometimes it may take 1 lakh iterations. Okay, based upon the problem. Then when you're showing every time, what happens? My weights will be stabilized. They will become constant. When weights are become constant, means what is happening? They capture this data information, the weights are captured. Therefore, when training is over, means my error will become very, very small. Error may become 10 to the power of -3, 10 to the power of -4 like that. Therefore, when error is become very, very small, my weights are stabilized correspondingly, then I will stop training. There is the training, what happened? The weights have captured the data's information they captured. That is what happened. Therefore, when weights are stabilized, then what I should do? Training. There are two things are there in the neural network, as I mentioned. One is the training, another one is the another one. Some answer I want. Training, another one. Nobody is answering.
Testing.
Testing means how we will do. Already my weights are stabilized. Therefore, at the time of testing, okay, I will give only input. I will get the corresponding output. That's why as I mentioned in the beginning, I told when we should use neural network, we should use neural network when you want fast computation, real-time applications when you want. When you don't want any fastness, then no need to use neural network. Therefore, in this, why it is becoming fast? Because Training, training and testing both are there, but training time we will not consider. Training time is 1 hour or 2 hours or 1 day also 24 hours, we will not consider. Training is always offline. Only testing is only online. Therefore, we'll give some input. Already weights are stabilized. We are not giving any new inputs, new weights. Weights are stabilized. Then what computer should do? It is doing only, as I mentioned, net it should calculate x1 w1 plus x2 w2, etc. Then if any activation function is there, calculate the output. Once again, output you should calculate. So only forward pass it will move. It will not modify the weights at the time of testing. That's why the computer to do, when I'm using i5 processor or i9 processor, then this computation will take very, very small. Based upon the processor speed, my testing time varies. It may become nanosecond, it may become microsecond. Okay, like that. That's much small time we cannot get by solving a set of equations by solving Newton-Raphson method or some other method. It is not possible. That's why in the training, what is happening is that the weights are capturing the data information or pattern information. Then after that, weights will be stabilized. Weights are stabilized means my error becomes very, very small. Error are small means my training is over. Now I will go for the testing. At the time of testing, I will give only input. I will not give the desired output at the time of testing. Corresponding the input, I will get the output. By that output, whatever I'm getting from the neural network, it should match the calculated value. Then it is doing correctly like that. Okay. Okay. This is about the requirements of the learning law. The fourth one, if you see, partial, if you see, learning should be able to capture complex nonlinear mapping between input and output pattern pairs. Strictly speaking, if you say this neural network, what is doing is that mapping problem. Input out, I'm showing input data. I'm giving first input, I'm giving error, I'm getting, and backward, I'm modifying the weights. Okay, once again, I'm giving input, like the process continues. That is, it is mapping between input and output. Okay, if you take very vaguely or statistical point of view, that is. Then if you see in one sentence, what is the objective of the learning law? Learning law, it may be supervised or unsupervised. In the supervised, we have seen three types, unsupervised, two types, whatever it may be. We are computing the change in the weight expression. What is the change? What is the need of the change in the weight expression? I should update my weights. Therefore, the objective of any learning law is that it should eventually lead to a set of weights which will capture the pattern information in the training set data. Once again, I'm repeating, the objective of any learning law is that it should eventually lead to a set of weights which will capture the pattern information. What is the pattern information? The patterns which are giving input and correspond desired output. Okay, the pattern information in the training set data. Okay. Therefore, in this one, we will have several problems will be there. Okay, as I mentioned, classification problem. Okay, supervised, unsupervised, it can do. Different will be. Okay, neocognitive transfer, one of the algorithm, adaptive learning, supervised, the self-organizing map comes under unsupervised learning. In the supervised, perceptron, multi-layer, backpropagation, radial basis function, etc., and all that. Okay, the problems can be a pattern recognition problem or pattern classification, function approximation, optimization, prediction, automatic control. The problems can be anything. Based upon this problem, we should select the particular paradigm. Okay. Before talking about this backpropagation algorithm, I will talk about one general way how to solve a problem. Okay. Because we want to solve if any problem, how to proceed. Then I will talk about this algorithms, whatever. As I mentioned in the neural network, two things are there. One is the training, another one is the testing. Okay, in the training, if you see, first of all, what we have to do is that we have to generate the patterns. Okay, how to generate the patterns, I will talk in the next class. Okay, we have to generate the patterns. Suppose you have generated 100 patterns, for example, or 1,000 patterns, for example. Whatever the patterns you have generated, because one thing you should remember, more data, more accuracy. Less data, less accuracy. Therefore, suppose I generated 100 patterns, for example, 70% of the pattern, because how to generate the patterns? You should generate randomly. Okay. When you generate randomly 100 patterns, what is the randomly? That point I will stress in the next class. Therefore, when you generate 100 patterns, out of 100 patterns, I should keep 70% of the patterns aside, separate I will make. Another 30% of the patterns I will keep aside. Once again repeating, what are the patterns you are generating? Separate 70% one side, 30% another side. This 70% of the patterns I will use in the training of the neural network. Okay. And second point, if you see, most of the time in electrical engineering, our data, voltage or capacity, we'll talk in terms of megawatts, okay, and kilovolts, etc. But weights, we are considering very small weights. Weights are within plus and minus 0.1 or 0.25, 0.5 like that, very small. If your values are very large in kilovolts and megawatts and weights are small, network may not learn. Network may not train. Therefore, what we are doing is that we are normalizing the data. How we are normalizing? Okay, there are several formulas are there. We are using this type of formula. Our entire data, why I use 0.5, 0.8 and 0.1 means entire data will come in terms of 0.8 and 0.9. Suppose you want 0.9 and 0.2 ankonde, then you can make it 0.8, 0.9. Here you can make it 0.2. Then what we are doing is that suppose whenever you are having entire data, from the data you pick which is the minimum value and you pick which is the maximum value. Then how I am normalizing your input? Okay, input minus minimum value into 0.8 divided by maximum minus minimum. This whole plus 0.1. Suppose your the value is whatever you are considering minimum is there. X is also minimum. It becomes 0. 0 by something 0. Then input becomes 0. It is not. It should not. That is why if it is 0, it will become plus 1 the value or plus 2, whatever the value you are assigning. Like that, I will normalize all the inputs. After normalizing, what we will do, as I mentioned, if you take a topology of neural network, input layer, hidden layer, output layer, weights will be there, input to hidden, hidden to output. Those weights should be initialized. Then after initializing, what we will do, select a suitable nonlinear activation function. What is nonlinear? Based upon the problem, you can take continuous activation function like sigmoidal or tan hyperbolic, etc. Okay. Then after selecting the suitable nonlinear function, then map. How we can map? Paradigm. As a
Hello. So, sir, I think you are stuck, or is it only happening for me? Okay.
Okay, in this training and testing, after generating the data, as I mentioned, 100 to 100%, 100 patterns are there. 70 I will keep one side, 30 I will keep one side. There was 70% of the data we are used for the training and the 30% testing. Therefore, from the 30%, we should pick the one input and the already the desired output. My neural network should give corresponding the desired output. Generally, up to 1% error is tolerable. Therefore, now one more thing, as time of testing, why you want to test 30% of the data? Only one or two patterns are not sufficient because we want to test that my network, it should be robust or not. Whatever the data you supply, my network should give correct results. Then we can say that's why we'll use 30% of the data is used for the testing of the network. Then for all the 30%, it is my results are okay. Then I can say my network is more robust. Okay, this is about the briefly with respect to the neural network of the paradigm. I not discussed anything. I talked topologies, learning algorithms, as well as the how to solve a problem. Okay, I will stop here. Therefore, before stopping, if you're having any questions, you can ask. Because paradigms I will talk on Friday. Next, some BPA and a radial basis function I will talk. Okay, it will take some time, and I should do some hand calculations also. Therefore, you also what you will do today is that for assignment, you take a neural network, some transformer. You take example for transformer, full load data. You take some output 3 kVA. My iron loss are 40, copper loss are 50. Okay, it's a full load. Assume. Okay, once again repeat. You note down if you want. My full load output is 3 kVA. Okay, and at a full load, assume power factor is 1. It is a 3 kilowatts. Full load iron losses 40 watts. Full load copper losses some 50 watts. That is. One data set is given. You calculate for the 1/3, sorry, 1/4, 3/4, and 1/2 like that. Corresponding each output, output of the transformer, calculate the copper losses. Your iron loss will be constant. After calculating copper losses, then calculate the efficiency. Efficiency eta 1, eta 2, eta 3, eta 4 you will get. 4 outputs you will get. 4 efficiencies you will get for the 4 patterns. Then you take one pattern. Now, what the input layer, the neural network, feed forward neural network, how it have input layer, how many nodes will be there? 3 nodes. Output layer, how many nodes will be there? Only 1 node. Hidden layer, 1.5 times the 3. 1.5 times 3, how much you will get? 4.5. You take 5 nodes in the hidden layer. You initialize the weights, input to the hidden, initialize the weights between some values you take it, W11, W12, W13, etc. Therefore, initialize some weights. Some similarly hidden to output. Okay. 1 into 5, 5 weights will come. Initialize the weights, some values. Then you give some input. Corresponding input efficiency is the desired output. You give that one. At least calculate one direction, forward direction. Input to the hidden to the output to calculate. This is the assignment for you to calculate. Any issue is there, I will try to explain in the next class. Therefore, before stopping, if you're having any questions, you can ask. No questions?
Sir, initializing the weights means we just put our numbers.
Initializing the weight means?
I didn't get what it means, initializing the weights.
Initializing the weights means suppose you are having suppose I will take only input layer, hidden layer, madam. Okay. Suppose input layer I'm having 2 nodes are there. Hidden layer I'm having 3 nodes are there. Okay. Then how many weights will come into picture? 3 into 6, 2. 6 weights will be there. W11, W12, W21. Is it not like that?
Right.
Therefore, how we initialize? Let's say as you consider plus and minus 0.5. Let's say I consider I want to initialize the weights from input layer to the hidden layer between plus and minus 0.5. Then
So
what I will do is that W11 I will take minus 0.1. Okay. W12 I will take minus 0.5. W13 I will take plus 0.25. Some values I will take. You take the, if you use in the random number generation, rand function is there. Okay. In the rand function, I will talk in the next class. Rand function, if you know the minimum value and maximum value, then I can generate, and you should give how many numbers you want. If a large data is there, we can do like that. Rand, that is rand function. Otherwise, what you can do hand calculations while doing hand calculations, when you are having input layer 2 nodes, hidden layer 3 nodes. Therefore, 6 weights are required. W11, W12, W13. Assume between plus and minus 0.5. Therefore, one you assign some positive value, someone you assign negative values like that. Same W21, W22, W23 is there. Assign some values, some value, plus 0.3, minus 0.3, some value assign. Because some connection is there from one neuron to another neuron, some weight is required, W, synaptic, what we call. Then whenever you are having this synaptic weight, okay, it will positive value or negative value is okay, but weight is 0 means there is no connection. The connection has gone like that. I followed?
Yes, sir.
Similarly, from hidden layer to the output layer. From hidden layer, 3 nodes are there. Output layer, 1 node, let us say. How many weights are required? 1 into 3. 3 weights are required. W11, W21, W31. Once again, you want to generate between plus and minus 0.5. Some number you give within that plus and minus 0.5. Plus 0.15, okay, minus 0.25, minus 3, some minus 0.3, like that you proceed. It's clear how to initialize the weights?
Yes, sir, got it.
If you initialize the weights, then what happens now? You give in the hidden layer and output layer some activation function. What is the activation function? Some sigmoidal activation function again. Then some inputs you take, transformer efficiency you take. Some 3 inputs are there, corresponding calculate the net one for the hidden node. Then what is the output is function of the net. What is the function? 1 by 1 plus e to the power of minus. Like that you proceed. Therefore, you put on a paper, okay, still any difficulty is there, I will try to explain. After explaining this forward pass, only one pass, input to the hidden to the output. Then backward, how to do in the next class. Therefore, if you know try to understand forward pass, I done one simple problem also in the beginning, okay, input to the hidden to the output. Then desired output is there, calculate the error. Then you stop. Still any issue is there? You can call me or you can ask in the next class. Okay, other than any other question? And after using this hand calculations, you can use the MATLAB toolbox. In the MATLAB toolbox, all these functions are there. The only thing is that you have to generate the data. If you generate the data is given to the neural network. You will get the network will be trained. After training, okay, how much error you are getting, that also will be displayed. After that, you can test. Okay, Simulink model will be generated. Then you can give some new input, corresponding output you are getting or not, you can check. Therefore, first of all, we should know most of the time the stress is that do hand calculation. Then you can use toolbox. Directly, if you use toolbox, what happens is that we are giving some input, we are getting the output. That's all. We don't know what is happening inside. That is the limitation. Any other question? Because I will feel more happy, more questions, more happy for me. Okay, you can pose any questions, and otherwise in the beginning, in the next class, when we meet on Friday, once again, you pose some of the questions I will expect. If there are no questions, I will stop. Questions are there? Okay, thank you very much, all of you. Okay, I'm leaving this session. Okay,
Thank you,
all of
sir.
you.
Thank you very much.
Thank you. స్టాప్ కాలే కదా